Hi, I want to spend a little bit of time today talking about the HashiCorp view on zero trust security, what it means and what the implications of it are. I think when we talk about zero trust networking, it's helpful to almost take a step back and talk about what was the sort of traditional approach to security and what were the implications of that. And so when we talk about the existing model that you predominantly see, it's very much what I like to call sort of a castle and moat approach. You have the sort of four walls of the data center, and we bring all of our traffic over sort of the front door. This is where our ingress and egress takes place. And this becomes the single sort of choke point where we deploy everything from sort of firewalls, web application filters, SIEMs, etc. So this is where all of our sort of networking gear goes. And what we do is we create this sort of binary distinction, right? Outside is bad and untrusted, inside is good and high trust. Now in a large network, we'd also segment this. So we might have some coarse-grained networks, right? This might be development, staging, production, PCI, etc. But these are still large-grained network segments. They might have thousands of nodes in each of them. Now, as we try and go to cloud, we add these nice fluffy cloud regions in. And each of these we connect together into effectively the super network, right? The super network can be constructed from different networking technologies. Could be SD-WAN, VPN overlay, direct connect, express route, etc. It's really this concept that we're bridging it all together into one giant network. Now, I think what you often see is how do we take this perimeter-based approach and extend it to these clouds, right? And get to a point where we have sort of 100% effective perimeter here. And I think what you find very quickly is if I'm going to give you any capability in the cloud, I'm going to give you any IAM permissions, I'm giving you enough rope to hang yourself, right? And what I mean by that is I'm going to give you the right to create an S3 bucket, for example. You might define that S3 bucket and mark it as public, in which case it's on the outside of your perimeter, right? In the same way that if you just change it to private, it's on the inside of the perimeter. So what you find is in cloud, the perimeter is really a logical concept. It doesn't exist in the same way it did on-premise when you literally had four walls and a pipe coming in, right? Everything was sort of inside your premise unless you explicitly made an effort to make it publicly accessible. And so what you quickly start to realize is, you really need to be comfortable making this 80% effective, right? And you can argue on exactly what that number is. If you're a pessimist, you might say it's only 50%. If you're an optimist, you might say it's a 99+% effective. As long as you pick any number that's not 100%, you break this model of the world, right? And I think this model fundamentally was flawed to begin with, right? When we said it was 100% effective, there's sort of two critical assumptions here. One is that of perfection, right? That I'm never going to make a mistake in my firewall, in my web app filter. I'm never going to have an out-of-date vulnerability. I'm never going to have a 0 day that's being exploited. And so it requires a certain level of perfection that's not realistic. The second is that it never contemplates an insider threat. It doesn't matter how tall my walls are or how effective my firewall is. If I've already given you, a VPN credential and you work for me and you're a malicious employee or contractor or subcontractor, right? So I think there was two critical flaws in this model to begin with. And so, in many ways, I think it's not a bad thing that as an industry, we're now moving away from it. So when we start to move towards this model where we say my perimeter is really, less than 100% effective, whatever that number is, and I consider the fact that really my adversary might be on network already, this is what brings you to fundamentally a zero trust networking model, right? And you can hear it be called different things: low trust networking, no trust networking, etc. The idea is that your core assumption is that your attacker is on your network, and so you don't trust it. It means we go away from this binary distinction of public untrusted, private trusted, right? That binary distinction kind of goes away. Yes, I still have a private network. No, I'm not making a distinction that that's a high trust environment in a way that the internet is not, right? They're all low trust, no trust, zero trust, right? So as we make this transition to sort of zero trust, our view is that there's a few different pillars of it to consider, right? So starting at zero trust, I think the next piece, the question is, well, what do we use as the unit of control? And what I mean by that is, in this world, in a traditional world, the IP was the unit of control, right? If you were within our private network CIDR or subnets, right, those were considered high trust and you were authenticated. If you're coming from the public internet, those IPs were untrusted, right? And so this might get expressed as something like a firewall control, right? The firewall is filtering, which set of subnets and which set of IPs are actually trusted, but we're managing it through a set of IPs. Versus as we move towards this sort of a zero trust setting, we don't necessarily care about the IP because again, we're moving away from this distinction. At the same time, as we go to these cloud environments, they're much more dynamic, much more ephemeral. We're spinning workloads up and down. So it's harder to manage a static set of IPs. And additionally, as we're crossing these different networking boundaries, IPs might be getting rewritten. We're going through NATs, we're going through different middleware appliances. So the IP is not a particularly portable or stable unit in that setting, right? So instead, what we want to do is hang our controls on identity. And when I talk about identity, what I really mean is it could be application identity, meaning this thing is a web server. It could be human identity and saying this is Armon. Armon is a database administrator as an example. And so we're using identity as the basis of how we're defining these controls. We would say our set of database administrators has access to our set of databases, right? That's an identity-based control versus saying IP1 can talk to IP2 as an IP-based control. So to make this work, our view is that there's 4 distinct pillars to think about, right? Pillar 1 is how do I actually think about machine identity? And so to make machine identity work, I need a strong notion of what is a web server, what is a database, what is an API, right? And here is where Vault plays. So when we think about what the role of Vault is, it's first and foremost to provide a sense of application identity, right? So when we have application identity, we can do this by integrating with all the different kind of platforms. So Vault will integrate with AWS and Google and Azure and et cetera, right? It'll also integrate with our platforms, things like Kubernetes, Pivotal Cloud Foundry, et cetera. So no matter where these applications run, we can map them in a consistent way into an identity and then define authorization rules on top of it, right? The most obvious application of this is great. Once we know that this thing is a web server and this thing is a database, is we can use that for secret management. So this is the common use case that people think about when they talk about Vault. Is great. I can use this to define, you're a web server, you get access to a database key, you get a TLS certificate, you get an API token, and Vault can broker and manage the distribution of those secrets and credentials, right? So that becomes a pretty obvious use case. The next one becomes data protection, right? So data protection, again, goes back to this model we have here, right? If we consider in this environment how we used to protect data, we used to maybe have a web server and the users would give us, let's say, a credit card or some social security or something, and then we'd write that to our database in plain text, right? So our database would store the credit card number or the address, etc. And if we were regulated, we might use something like, an HSM device and turn on transparent disk encryption so the database is encrypting its data at rest. And so the threat model for this is really that someone knocks down the door of my data center, finds the hard disk that has customer data, pulls it out and exfiltrates it, right? What this doesn't contemplate is a network-based attack. In this scenario, if I'm an attacker and I can get to the database on the network and I can select data out from that, well, transparent disk encrypt is also transparent disk decrypt, right? The database will happily read it from disk, decrypt it, and send it out over the wire, right? So it's clear in that case that it didn't really add much from a data protection standpoint if our threat is one of network and not one of a physical breach. So in this last use case, you really think about Vault as a way of encrypting that data, right? So when that web server gets the unencrypted data, it gets the credit card number, the social security number, etc. That goes to Vault. Vault then encrypts it with a set of encryption keys that it has. It does not expose to the application. And then it hands the safe ciphertext back to the database. To the web server. And then the web server can store that data in the database. So in this case, what we're storing in the database has already either been encrypted or tokenized. So now even if an attacker can get to the database, they need a second factor attack where they're able to be authenticated against Vault, and they need to be authorized to decrypt it or detokenize that data. So really looking at, in this sort of a zero trust world, how do we think about data protection and how that evolves? It's not enough for us to just consider that our database is behind the four walls or it's behind the perimeter. We add those additional layers of you need specific authentication and authorization to decrypt that data as well, right? And so that adds an additional layer of defense. So this is where Vault sits. Then the next challenge sits way on the other side of the spectrum, right? So on the other side of the spectrum is how do you think about human identity? And this is a much more solved problem. Ultimately, this boils down to basically single sign-on as well as having a common directory. So in a previous generation, this would have been largely Active Directory on-premise serving this role. Now in a cloud world, it might be Azure AD, might be Okta, might be Ping, might be Centrify. There's a lot of different answers. But what it boils down to is I want a common directory of all my employees and maybe what groups they're in. So I know this is a set of DBAs, for example. And then the single sign-on is I need some cryptographic way to assert that identity in other systems. That might be OIDC, and I have a JOT token that's signed. It might be SAML, and I'm making an assertion about these users. So there's a number of different tools and technologies, but it kind of boils down to the same thing. I need a common directory, and I need some form of SSO, OIDC, SAML, etc., that I can consume that identity in other systems. Once I have these two pieces, I have a strong notion of who the people are that are identifying themselves and logging in, and I have a strong notion of the applications and the machines and what their identities are. Then I have the two middle workflows, right? And there's kind of, only two if we complete this matrix, right? Which is one is machine to machine, or app to app, you might call it, and the other is human to machine. And so in both of these two use cases, our challenge is how do we use the identities that we have and then use that to enforce control, right? And restrict who's allowed to talk to who. So the authentication might be coming from the identities that we already have, but then we're layering an authorization layer to make sure that only the apps that should talk to other apps do so, and only the people that talk to the apps they're supposed to. So here is where Consul fits. So Consul is HashiCorp's service networking tool, and there's really three key problems this solves, right? The first is service discovery. And so with service discovery, we start with the challenge of how do we even know what all of our applications are? Where are they? In most environments, there isn't really a catalog that says these are where all my apps are, these are all the services that I have. It's sort of an emergent property, right? There's things all over the place. So the first thing Consul solves is it gives us a consistent catalog where we can integrate it with all of our different systems, be they mainframe, VM, containerized, serverless, etc. Consul integrates with all the different platforms. And so it gives us kind of this bird's eye view of what everything is. Then on top of that, you can implement a service mesh, right? So Consul can act as the central control plane where then we can define these central routing rules, right? So we can define rules that say, great, my web server is allowed to talk to my database. My API is allowed to talk to my web, right? So that control, again, is an identity thing. We're saying web server to database is allowed. I'm talking about it at an identity level. And then how do we enforce that? Well, the way service meshes work under the hood is we're distributing a set of certificates to the different applications, right? That certificate encodes the identity, right? So the web server gets a cert that says it's a web server, the database gets a certificate that says it's a database, and it's cryptographically signed, against a certificate authority that's trusted by our different nodes, right? And then the proxies, when they communicate between one another. So when the web server talks to the database, it's going through a proxy. Similarly, the database has a proxy terminating on behalf of it. Could be Envoy, HA proxy, Nginx. The first thing those proxies do is they authenticate, is this a valid certificate that's signed? Yes or no. So now we have a strong notion of the identity on the two sides. We know it's a web server talking to a database. Then the next layer is, are they authorized? So that's when the proxy will interact with Consul as sort of that central source of truth to say, great, I'm a database, a web server is connecting to me. Is that allowed? Yes or no, right? And so now you can see what we're getting at is now we have an explicit control that we defined that says web server to database is allowed. We're doing it at this identity-based level. We don't talk about IP1 to IP2. And we're using this mesh-based approach to actually enforce that control, right? Now, it would be nice if all of our networks could just live in this mesh-based world, but in reality, we have existing networks. They operate in sort of an IP-centric way. We might have firewalls and gateways and WAFs already implemented. So the third piece here with console is what we refer to as network middleware automation or network infrastructure automation. And the challenge here is I still want to define this identity-based control that says web server talks to database, but it might be that I'm not using a service mesh. It might be that I have a firewall, I have a Palo Alto firewall as an example, in between them. So in this use case, what we would do is we would write a bit of Terraform configuration, so going as infrastructure as code, to basically say, hey, my source inputs from console are the set of web servers and the set of databases. And then given that, I'm going to define how should my Palo Alto firewall be configured. And so what that configuration then does, we give that to console. And so the moment a new web server is registered or a web server is deregistered or its health status changes, console will detect that, oh, this bit of Terraform code needs to be re-executed because it has a subscription or a dependency on the set of web servers or the set of databases. And so this allows us to start with that catalog of we know all the different services. As those things come and go, we can trigger automation and use Terraform to then update our firewall, our gateways, our various networking middleware devices. And as part of this network infrastructure automation, we've partnered closely with all of the major networking providers: Cisco, Juniper, A10, Checkpoint, Palo Alto. There's a longer list available on our website. And so you can see how this then enables us to operate in sort of this hybrid mode, right? Where console's giving us the central catalog, we can have our new greenfield applications operating in a pure service mesh, and we can have that integrated to our more traditional networking environments using network infrastructure automation, right? So it gives us kind of a holistic way of moving towards this identity-based model of handling the machine-to-machine networking, right? Then as we talk about the last use case, it's about human-to-machine, right? And this is where our newest product, Boundary, fits in. And so when we talk about human-to-machine, often there's sort of a gauntlet of steps users have to go through, right? They first have to connect to a VPN, or maybe they're going through an SSH bastion. That puts them on the private network. Because we don't want them to have access to everything, there's typically a firewall in place to restrict, great, if you're coming in from a VPN, what set of network resources are you allowed to connect to? So now you have to manage a set of firewall rules around who can connect to what, right? And then from there, if I'm connecting to, let's say, a database, I might want to do session recording, or I need to have privilege access management to restrict who has access to database passwords. So now I have to log in and use a privilege access management tool. That might be imposing session recording. And then finally, I connect to my target destination, which might be the database, right? So we looked at that and said, is there a way to simplify this where you just have a single point of entry? And that's really what Boundary is, right? So the idea is I don't have a separate set of VPN credentials, and I don't have to have a separate set of SSH keys. I do a single sign-on, right, via my IDP, right? So tie it back into this human identity we already have, and that's how I authenticate. I don't need a separate VPN or SSH credential, right? Then the second piece is I really don't want to be in the business of managing 3 different sets of overlapping controls, my VPN plus my firewall plus my PAM plus my database. I really want a logical control that says my database admins are allowed to talk to my databases, right? Again, going back to an identity-based, service-based control. And so that's how the authorization works here, right? So I have a logical sort of off the Z that operates at that service level. And that's how I specify who's allowed to do what, right? Then the advantage is Boundary, unlike a VPN or unlike SSH, doesn't actually give you direct network access. It won't put you on the network. So I don't need a separate set of firewall controls. Boundary will only allow the user, based on their authorization, to talk directly to a target instance. And that's happening from the Boundary gateway directly to that instance. There is no private network access. And so we don't need a second level of firewall to restrict what you can do, right? So this eliminates multiple layers. I don't need to first have a VPN and SSH. I just talk directly to the Boundary gateway. I don't need another layer of firewall because I don't give you network access. And then Boundary can directly inject the credentials and in the future provide the session recording as well. So I don't need a separate layer of privilege access management either, right? I talk from a user's point of view directly to the Boundary gateway. It authenticates me, it authorizes me and connects directly to the target instance. And because it's in that middle point, it can inject the credentials as well as perform the session recording. So it simplifies that end-to-end access, right? And so it's a simple solution that then covers the sort of end-to-end use case, right? Otherwise, we'd have 3 or 4 different pieces of control we'd have to interpose. So taking a zoom out, again, as we talk about zero trust, it's a much bigger space, but it really starts with this idea of, I don't want to provide any sort of a high trust assumption, right? I don't trust my network. That means everything needs to be explicitly authenticated, explicitly authorized. And so if we're going to hang everything off of identity, then the first starting points are, do I have an understanding of human identity? Do I have an understanding of my machine identity? Once I have that, I can leverage those to solve the 2 key networking flows, right? App to app or machine to machine using console, and human to machine using boundary, right? So hopefully that gives you a sense of sort of how we think about zero trust and what we need in terms of the 4 pillars as we're transitioning to that. Thanks.